Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children. So we finished exercise 11.1 from NCERT. This is the next exercise 11.2. Example 1. So here we have to find the area of the quadrilateral PQRS. The figure is given to us. We need to find the area of the quadrilateral PQRS. So area of quadrilateral is given by the formula. See here. Now you can find the area of this quadrilateral in two ways. What is the area of triangle? What is the area of triangle PQS, children? What's the area of triangle PQS? What's the formula to find the area of a triangle? Half base into height, correct? Half base into height. Half into base into height. So in triangle PQS, which is the base, half into the base is QS. And the altitude is, if I mark this point as, if I mark this as say M, I mark this as M and I mark this as N. I mark this point as N. Okay, so supposing I call this point M and this point N. So it will be half base QS into altitude, which is the altitude on the base QS PM, correct? PM. So that will be half into base QS. What's the length of QS? 5.5. That's what is marked there. 5.5 into the height PM, which is 1.5. And how do we calculate this? This is equal to multiply. You cannot simplify. You can simplify, like if you want, you can divide 5.5 by 2. You will get 2 2s are 4. 1 remains. Keep a point. Bring the 5 down. 7s are 14. 1 is a remainder. Add a 0. 5s are 10. So it's 2.75. When you divide 5.5 by 2, it's 2.75. 2.75 into 1.5 into 1.5. Find this product. Find this product, children. 2.75 into 1.5. 4.125. I use the calculator. 4.125 centimeters squared. Please write down. We haven't answered the question. We have only found the area of triangle PQS. We have not answered the question. Write down quickly. All right. Then next we'll find the area of the other triangle. Which is the other triangle? Which is the other triangle?
Triangle QRS.
QR?
Yes, ma'am. Yes, ma'am.
Yes, yeah. Area of triangle QRS. QRS is equal to half base into height. Half into base into height. So which is the base of triangle QRS?
QS.
QS into altitude?
RN.
RN. Now, what's the length of QS?
5.5 centimeter.
5.5. And the length of the altitude RN?
2.5 centimeter.
2.5. 2.5. So again, when you divide 5.5 by 2, you'll get the same thing, 2.75. When we divide 5.5 by 2, you'll get 2.75 into 2.5. That is equal to, I'm using the calculator, 2.75 into 2.5, 6.875. 6.875 centimeters square. Now you must say this is the third step. This is the third step. There's no place for writing it here, children. So area of, don't write in the middle, children. Please write one below the other. Don't write it side by side like this. You always write one below the other. So this is the third step. Area of quadrilateral PQRS. See, I'm not using short forms. This is how we write. I'm not using short forms. These are the standard ways of writing. You can write area of triangle PQs like this. The standard way of writing. I'm not using any shortcut. Sorry, short forms. Not shortcut, short forms. It's a standard way of writing. So area of quadrilateral PQRS is equal to area of triangle PQS plus the area of triangle QRS. Area of triangle PQS plus the area of triangle QRS. So that is equal to 4.125 plus 6.875, which is equal to at 0, 1 carry over, 0, 1 carry over, 0, 1 carry over, 11. I think it's 11.000, which is 11 centimeters squared. Please check, children. I might be wrong. Please check. So the area of the quadrilateral PQRS is equal to area of triangle PQS plus the area of triangle QRS. And the formula to find the area of a triangle is half base into height, or half base into corresponding altitude. Height is the corresponding altitude. Yes. Finish writing, children? No. Yeah. All right, children. Now you'll see a formula. Now you will see a formula to find the area of the quadrilateral. Now we'll see for this is without using the formula, that is finding the area of the two triangles using the formula half base into height, and the sum of the areas of the two triangles is equal to the area of the quadrilateral. Now see here, this is the formula to find the area of a quadrilateral. This is the formula to find the area of a quadrilateral. Half D into H1 plus H2. Half D. Area of quadrilateral PQRS is equal to half D into H1 plus H2. Now what is D? D is the diagonal. Now we know that a quadrilateral has two diagonals. See here, QS is one diagonal, and when you connect PR, PR is the other diagonal. See here, quadrilateral PQRS, let me just show you here like this. Okay, so quadrilateral PQRS. See, this is one diagonal. QS is one diagonal. The other diagonal is PR. The other diagonal is PR. A quadrilateral has two diagonals. So here it is diagonal QS and diagonal PR. So half D is half diagonal, whichever diagonal is given. Okay, half D into H1 plus H2. So you see here, what is PM? What are PM and RN? PM is an altitude on the diagonal QS. RN is also an altitude on the diagonal QS. PM is an altitude on the diagonal QS. See that it touches QS. It's perpendicular to QS. PM is perpendicular to QS because it makes 90 degrees. PM is perpendicular to QS, the diagonal QS. Similarly, RN is perpendicular to the same diagonal QS. So PM and RN are perpendiculars on the same diagonal QS. So they are regarded as H1 and H2. You can take anything as H1. You can call this one H1 and this one H2, or you can call this H1 and this one H2. That's okay. So the formula to find the area of a quadrilateral is half D into H1 plus H2 square units. So half into diagonal here. Diagonal is QS, which is 5.5 into H1 plus H2. So into 2.5 plus 1.5. 1.5. Now 2.5 plus 1.5 is 4. So half into 5.5 into 4. 2 ones are 2 twos are. So 5.5 into 2, which is 11 centimeters square. The same we got here. We got the same answer here. But we took a little longer time to work this.
In a quadrilateral, a diagonal doesn't divide the quadrilateral into two equal halves.
No, not in every quadrilateral. In a quadrilateral, the diagonal need not divide it into two equal halves. No. Will be special quadrilaterals where the diagonal will divide the quadrilateral into two equal halves. In general, it's not true in a quadrilateral. So this is how you should work, children. You should use the formula. You should use the formula half d into h1 plus h2 to find the area of any quadrilateral. Done, children?
Done, ma'am.
Yeah. Now we'll see how we get this formula. Okay. We'll see how we get this formula. Now I'll call this diagonal QS as D. And this altitude as H1 and the other altitude as H2. Now tell me, in terms of D, H1 and H2, what is the area of triangle? What is the area of triangle PQS? Or we'll do QRS first. What is the area of triangle QRS? Half base into height, right? Half base into height.
Yes, ma'am.
So half into D into H1, correct? Half D into H1. Half base into height. Half D into H1. What is the area of triangle QPS? QPS half into
Half diagonal into H2, ma'am.
no, we'll not say diagonal. It is base only. I'm just calling the base as D. I'm just calling the base as D and the altitudes as H1 and H2. We're using the formula to find the area of a triangle, half base into height. What is the base called? D. And what is the height called? H1 in the first triangle. In the second triangle, the base is again D, half base. So half into D into height, which is H2. Now, how do you find the area of the quadrilateral? Area of quadrilateral PQRS. Area of quadrilateral PQRS.
Half into D, H1 plus H2.
Half into, yes, D into H1 plus half into D into H2, correct? Yeah, what is common now? What is common between this and this? What is common between these two? Half D is common, correct? Half D is common. So we'll take out half D common outside. So what should we write in the bracket? H1 plus H2. That's how the formula is derived. Half D is common. So write it out. Then what is remaining? Half D is outside. So we should write H1 plus half D is outside common, H2. Like if you have AB plus AC, if you take out A common, in the bracket you should write B plus C. If you take out A common, in the bracket you must write B plus C because A into B is AB plus A into C is AC. Similarly, half D is common. Half D into H1 will give you the first one, plus half D into H2 gives us the second one.
And we are using the distributive property.
Yeah, the distributive property. Correct. Distributive property of multiplication over addition. Yeah, children, if you're interested, you can make a note of this. I'll just give you some time. Yeah. Is it understood, children?
Yes, ma'am.
Okay. Okay. Next one. Find the area of a rhombus whose diagonals are of lengths 10 centimeters and 8.2 centimeters. Now, the formula to find the area of a rhombus is base into height. If the value of the base and height is given to you, so you have two formulae. Area of rhombus is equal to base into height. Base into height if this information is provided. If this information is provided. Square units. Or you can also find the area of the rhombus using the formula. Area of rhombus is equal to half product of diagonals. Half product of diagonals. Product of diagonals. Okay, so symbolically, this formula, symbolically, we write it as half into D1 into D2. D1 and D2 are the two diagonals. A rhombus is also a quadrilateral. It has two diagonals. A rhombus is also a quadrilateral. It has two diagonals. So the diagonals are called D1 and D2. The formula to find the area of a rhombus is half product of diagonals, which means half into D1 into D2. So if you have the information regarding the base and height, use the formula base into height. So here we are given the lengths of the diagonals. So we have to use the formula half D1 into D2. Work this, children. Write down the formula, sorry.
D1 plus or into
Yes, Nandana?
D1 is plus or into.
Nandana, you're very soft, Nandana. Louder.
Is it D1 into D2 or D1 plus D2?
No, darling, it's not half sum of the diagonals. It is half product of the diagonals. Half into D1 into D2.
But you told that rhombus has two diagonals.
What did I say?
But you told that rhombus has two diagonals.
Yeah, it has two diagonals.
Only sometimes we do it.
A rhombus has two diagonals. One diagonal here we call D1, the other diagonal D2. Every quadrilateral has two diagonals. Here, the two diagonals are called D1 and D2.
Done, ma'am.
Yeah.
Done, ma'am.
Yeah, Chitra.
Ma'am, please wait, ma'am.
Yeah, okay. You want me to show you this slide?
Yes, ma'am.
Okay.
Ma'am, done, ma'am.
Yeah. So you can also write it like this. You can also write it like this. 1 second. Half D1, D2 is also, the meaning is half into D1 into D2. Half D1, D2 is the same as half into D1 into D2. You can write into here. Into. Yes? Swati, you asked me something?
Yes, ma'am. If the measurement of the base and height is given, can we use base into height?
Base into height, yes. We'll use base into height.
Done, ma'am.
Yeah.
Done, ma'am.
Yeah, Chip. So how do we simplify? 2 ones are 2 fives are and 5 into 8.2. Or you can, smartly you can do this. 2 ones are 2 4.1 times. And 4.1 into 10 is 41. You don't disturb the 10. 2 ones are 2 fours are 8. Yeah. 2 fours are 8.1. 2 ones are 2. So 4.1. 4.1 into 10 is 41 centimeters squared.
Yes, ma'am. I did 10 into 8.2 is 82 and by 2 and 14 centimeters.
Okay, see what is we should simplify first and then you should not, see, I'm not saying you don't find okay, 1 minute, 1 minute. Let me just give you an example for now, supposing you had 625 into, just for example, okay, 144 divided by 25 into 12. All right. All right. Now, why do you want to multiply 624 and 625 and 144? Get a huge answer. 25 and 12, get another answer, and then divide these two. See, you'll take some time to multiply these two numbers, and some more time to multiply these two numbers, and some more time to divide and find the quotient. Instead, what you should do, you must first simplify, and the leftovers you should calculate. So what should you do? 25 ones are 25, 25, 25 times 625. 12 ones are 12, 12 12s are 144. Now see, your work is so simple. 25 into 12, 300. Finished. Otherwise, you would have spent time multiplying 625 and 144. Then again multiplying 25 and 12. And then you will have two numbers. You have to divide them and then get this 300 as quotient. So you should never multiply like that. You should always simplify. See here, 2 ones are 2 4.1 times. Should first simplify like this. Now further simplification is not possible. Then you multiply. 4.1 into 10 is 41. Children, this reminds me of something else. In the last class, because I completely forgot to talk to you about the simplification part. God. Where am I? Yeah. Here, children, I did not, tell you about how to simplify. So here, see here, 7 ones are 7 0.2 times. See, one more thing, oh my God. If you're not, you should, but in case you're not comfortable with decimals, you can always write 1.4 as 14 by 10. See, but you should learn, you should start practicing, decimal division and get used to it. That will be the wise thing to do than escaping that. I'm just telling you an alternative. 1.4 can also be written as 14 by 10. And you can simplify like that. So now 7 ones are 7, 0.2 times. 7 0.2 times. See here, multiply 7 and 0.2, multiply, what do you get? 7 twos are 14. And then after the decimal point, there is one digit. So here, 1.4. Multiply 7 and 0.2. 7 into 0.2. 7 twos are is 14. And decimal point. After the decimal point, there's one digit. So you'll have to place it here, 1.4. So how do we simplify? 7 ones are 7 0.2 times. Then when you multiply 22 and 0.2, 22 into 2 is 44. After the decimal point, there's one digit. So 4.4 plus 2.8, which is 7.2. Here also, same thing, children. 7 ones are 7 0.2 times. Then 22 into 0.2 is 4.4. Because 22 into 2 is 44. And after the decimal point, there is one digit. So 44 is the product. Now, if you place a decimal point here, see here, after this, there is one digit. So 4.4 plus 5.8, which is 10.2. Similarly, 7 ones are 7 0.2 times. 22 into 0.2 is 4.4. Yeah. So 22 into 0.2 is 4. I'm sorry, I'm just not getting the. Okay, yeah. So 22 into 0.2 is 4.4 plus 4 plus 4. How do you add this? See here, 4 means 4.0 and 4.4. It's like this, which is 8.4. Don't add 4.4 and 4 like this. It's not like this. It's not 4.4 plus 4 like this. 4.8. 4 means 4.0 and 4.4. 8.4. So 8.4. Yeah, just wanted to tell you this. Yes, children, this is the next one. The area of a trapezium-shaped field is 480 meters square. The distance between the parallel sides is 15 meters, and one of the parallel sides is 20 meters. Find the other parallel side. Now, this is a trapezium, and the formula to find the area of a trapezium, is half into sum of the parallel sides, into distance between the parallel sides, Now, see here, if I, 1 minute, let me draw the trapezium first, sorry. One minute, let me write it again. 1 second, please. Yeah. Okay, so what is the sum of the parallel sides? A plus B. What is the distance between the parallel sides? H. H is the distance between the parallel sides. So half into A plus B into H square units is the formula to find the area of a trapezium. The parallel sides here are A and B. The parallel sides here are A and B, and the distance between the parallel sides is H.
And can we write as A plus B by 2 into H?
Yeah. A plus B into H by 2. Yes, you can also write it as A plus B. A plus B into H by 2 into H. Oh, sorry. But this is easier to. You can also write it like this into H by 2. Yeah, this is correct. You can write it like this, but I don't want to. This is also right. A plus B into H by 2 is also correct. Yeah. Finish writing this, children?
Will a trapezium always look like this, or it will change like quadrilateral one?
Yeah, trapezium can also look like this. No, it can also look like this. It can also look like this. It can look, there's an isosceles trapezium where the non-parallel sides are equal. It can be like this.
What is the exact definition for trapezium?
A trapezium is a quadrilateral in which one pair of opposite sides are parallel. A trapezium is a quadrilateral in which one pair of opposite sides is parallel.
Yes, ma'am.
For the formula, can we also, for the 1 by 2, can we also write the division, ma'am? Like 2 divided by A plus B into H.
How?
No, ma'am. Like 2, ma'am. Sorry, ma'am, I got collapsed.
That's what you know. Actually, even I was like trying to figure out what you said. Okay.
No, ma'am, for finding the no, just leave it, ma'am.
If you have a doubt, you can ask me. But okay. Yeah. Yes, one second. Let me just finish with Swati. So, Swati, are you there? So this is an isosceles trapezium.
Yes, ma'am.
Okay, so this is a trapezium where this is the distance between the parallel sides. One of the sides itself is the distance between the parallel sides. We'll see all this. In the same exercise, we'll see all this.
Okay, ma'am.
Yeah, a trapezium can look like this also. So what I've drawn there, like this, and this side longer, like this. These two sides parallel.
Yes, ma'am.
Can
Ma'am,
look.
when written the A, it will be parallel to B, ma'am.
Yeah, in this figure, A is parallel to B. That's why I've marked the arrows here like this. A is parallel to B. Yes.
Ma'am,
Yes.
I'm having doubt in trapezium sum which have given in school
Yeah, please ask me. Yes.
because they have wrote the sum like sentence ma'am, so I can't understand.
No, I've written no half into A plus B into H. What is it you've learnt in school?
From my understanding part later, they have given like a sentence ma'am.
Sentence, huh? Sentence, is it?
Yes, ma'am.
No, you will, if you're more clear, like a sentence, meaning what sentence?
Can I take my classwork?
No, I'll tell you one thing. You can just take a picture and send it to me later. I'll clarify that. Okay, and remind me in the next class also. I'll tell the others also about it.
Okay, ma'am.
Yeah. Please, don't forget to send.
Okay.
Yeah. Yes, children. So area of trapezium is equal to half sum of the parallel sides. That is what is A plus B. Half into sum of the parallel sides, A plus B, into the distance between the parallel sides. In the figure, the distance between the parallel sides is H. So half into A plus B into H. So how do we work this? See here. Area of the trapezium is given to be 480 meters square. Okay. So half H into, you can also write it like this, children. Half H into, it's a product, right? So half H into A plus B, or half into A plus B into H. It's all the same. Don't get confused. Just that multiplication sign is not there. Even if it's not there, the meaning is the same. 1 minute. See here, children. Half into A plus B into H. Without the multiplication sign. Half A plus B into H. It's the same. Or you can also write as half H into A plus B. All the same, children. All the same. So half H into A plus B is equal to 480. So half into, what is H? What's the distance here? Distance between two parallel sides is 15 meters. So H is 15. One of the parallel sides is 20 meters. So A is 20. The other one we don't know. B we do not know. Is equal to 480. So in this formula, half H into A plus B, we know H 15. That is the distance between the parallel sides. 15. So H is 15. A, one of the parallel sides is 20. So A is 20. We have to find the length of the other parallel side, which is B. So work this and find the area, find the value of B. So this is nothing but 15 by 2. Half into 15 is 15 by 2. 15 by 2 into 20 plus B is equal to 480. So 15 by 2 on the other side will become 2 by 15. 15 by 2, when you transpose, it becomes 2 by 15. So 20 plus B is equal to 480 into 15 by 2. When you transpose, it becomes 2 by 15. Now simplify in the tables of 15. 15 ones are 15. 15 threes are 45. 3 is the remainder. 15 twos are 30. So 20 plus B is equal to 32 into 2 after simplifying. So 20 plus B is equal to 64. B is equal to 64 minus 20. B is equal to 44. So the length of the other parallel side is 44 meters. The length of the other parallel side is 44 meters. You can even draw a diagram to write this information. So see here. How much is this? 20 meters. This is B. We do not know B. And H is 15 meters. This is 15. The area is 480 meters square. A is 20. A we know is 20. B we do not know. H is 15. Work this, children. Please work this. I'm just coming back. Done, children?
Done, ma'am. Yeah, ma'am.
All right.
Done.
Yeah. Find the area of a rhombus. Sorry, the area of a rhombus is 240 centimeters square and one of the diagonals is 16 centimeters. Find the other diagonal. How do we do this? What's the formula to find the area of a rhombus when the diagonals are given?
I'm half into product diagonals.
Half into D1 into D2. So what is the area given?
16 into D2.
Correct. What is the area of the rhombus given? 240. Area is equal to 240. That means half D1 D2 is equal to 240. Now half into what's the length of one diagonal?
16.
16 into we have to find the length of the other diagonal. So into D2 is equal to 240. Now simplify. 2 ones are 2 eights are. So 8 into D2 is equal to 240. D2 is equal to 240 divided by 8, which is 30. So the length of the other diagonal is 30 meters, 30 centimeters. Right down, children? Please write down.
Ma'am, at last the other diagonal is 30 centimeter. Ma'am, you have given it as
Oh yeah, sorry. Centimeter, children. Yeah. 30 centimeter. Length of the other diagonal is 30 centimeter. Yeah.
Done, ma'am.
All right, children. Any queries related to the calculation?
No, ma'am.
Okay. All right, children. Yeah. Now there is a hexagon MNOPQR. So a hexagon is a polygon with 6 sides. A hexagon is a polygon with 6 sides. So there is a hexagon MNOPQR of side 5 centimeters. So it's a regular hexagon of side 5 centimeters, meaning it's a regular hexagon. A regular hexagon is one in which all the sides are equal and all the angles are equal. A regular hexagon is one in which all sides and all angles are equal. Now, for example, a square is a regular polygon. A square is a regular polygon because in a square, all sides are equal and each angle is equal to 90 degrees. All the angles are equal. A rectangle is not a regular polygon. A rectangle is not a regular polygon because in a rectangle, only opposite sides are equal. All angles are equal, but all the sides are not equal. So a square is a regular polygon because all the sides of a square are equal and all the angles of a square are also equal. Similarly, an equilateral triangle is a regular polygon. An equilateral triangle is a regular polygon because in an equilateral triangle, all the 3 sides are equal and all the angles are equal. Each angle is equal to 60 degrees. So a regular polygon is a polygon in which all sides are equal and all the angles are also equal. Now here it's given hexagon, but since it's mentioned offside 5 centimeters, so we understand that it's a regular hexagon because offside 5 centimeters meaning it's a regular hexagon. Aman and Ridhima divided it in two different ways. Find the area of this hexagon using both ways. Now this one is actually simple. I don't want to explain first, so I'll show you the answer slide. I want you to go through, try to understand how much of you can and finish working, and then we'll discuss. So here you can see the answer.
Mama used the trapezium method and Ritma used by splitting it.
Yeah, Aman has divided the hexagon into two trapezium, one here and one here. Ridhima has divided the hexagon into two triangles and one rectangle. In Aman's case, there is a trapezium here and a trapezium here. In Ridhima's case, there are two triangles and one rectangle. Yeah. So this is the original figure, children. This is the original figure. This is the original figure. This is how Aman has divided it. And this is how Ridhima has divided it.
Can I show the question?
Yeah. Yeah, please take down the diagrams, children. Yeah, thanks, Swati. I'll just come back, children. Please write down the question, draw the three figures. All right, let's discuss the first one, Aman's method. So how has Aman divided the hexagon, children?
I'm into two equal trapeziums.
Two trapeziums, two equal trapeziums. The plural of trapezium is trapeziums or trapezia. Trapeziums or trapezia. Trapezia. You can say two trapezia or two trapeziums. Okay, Aman has divided the hexagon, the regular hexagon, into two trapeziums or two trapezia. All right, so now how do you find, so name the two trapeziums. Name the two trapeziums, children.
Trapezium NMRO and trapezium NOPQ.
NOPQ, then what's the other one?
Trapezium NMRO RQ.
No, we shouldn't say MNRQ. See, when you say MNQR, MNQR, or you must say MRQN. You cannot say MNRQ. See, like when you have a rectangle like this ABCD, you cannot say rectangle ABDC. It is rectangle ABCD. You must use the vertices in the clockwise or anti-clockwise direction. You can also say DCBA, or you can say rectangle CBAD, or you can say DABC. But you cannot call this rectangle CBDA. When you have a rectangle like this, ABCD, you cannot call it CBDA. When you say CBAD, it is. You need to name it in the clockwise or anti-clockwise direction. So you can say trapezium MRQN, MRQN, or you can say MNQR. And what's the other trapezium? The other trapezium is this one, NOPQ, this one, NOPQ. Now we need to consider the altitude. See, now you can see here MS. MS is perpendicular to NQ. You can see here we have taken MS perpendicular to NQ, and we have also taken PT perpendicular to NQ. Now what's the formula to find the area of a trapezium? Half sum of parallel sides into distance between them. Half into sum of the parallel sides into distance between them. So when you consider this first trapezium, MNQR, this one, half into sum of the parallel sides. These are the parallel sides. These are the parallel sides. In this trapezium, these are the parallel sides. Okay, so half into MR plus NQ. See here, MR plus NQ, sum of the parallel sides into the distance between them. See here, this is the distance between the parallel sides. This is the distance between the parallel sides. These two are the parallel sides. You can see them. They are parallel. They are parallel. This line and this line. They are parallel to each other. These two are parallel. So MR plus NQ into the distance between them, MS. Similarly, in the other trapezium, OPNQ, in this one, half into sum of the parallel sides. These are the parallel sides. These are the parallel sides. See here, this one and this one, they are the parallel sides. So half into OP into half sum of the parallel sides. OP plus NQ. Half sum of the parallel sides. OP plus NQ into the distance between them, PT. See, these are the parallel sides. This is the distance between the parallel sides, PT. PT is the distance between the two parallel sides, PT. So we have written the formula. Now let's substitute the values. Half into what is MR? It's given that each side of the hexagon is 5 centimeters. So everywhere it is 5. Off side 5 centimeters, meaning everywhere it is 5. The side is 5. That's what is given. It's a hexagon of side 5 centimeters. That means it's a regular hexagon of side 5 centimeters, meaning all the sides are 5 centimeters each. So in the first trapezium, this one MR is 5. This is 5. What's the length of NQ? NQ, you can see it outside here. Can you see here? This one is 11. What is this one? From this point to this point. See, it's marked. It's marked here. This one. See here, from this point to this point, to this point. So that means this one is 11. That's what is marked outside here, 11. See, this one is 11. That's what is marked outside, 11. So half sum of the parallel sides. MR is 5. This is 5. NQ is what is marked outside from here to here, 11. 11. This is one, the other parallel line is 11. One of the parallel lines is 5, the other one is 11. Into distance between them. Distance between them. That is MS. This is the distance between them. You can see this here, children. 8. 8 is what? From here to here. From here to here is 8. See here, it's marked here. You can see. See here. This point to this point. Okay, I showed it here. It's the same. From here to here. It's the same, children. I'll show you again. See, you can see these two lines here. Okay, so the distance between these 2 points, is 8. That's what is marked outside. This one is 8. This one is 8. That is, see here, children. This one is 8. This one is 8. This one is 8. This full thing. RP. This one is 8. So it will be 4 here and 4 here. It will be 4 here and 4 here. If this is 4, this is also 4. Am I clear?
Yes, ma'am. Yes, ma'am.
Okay. So RP is 8 centimeters. See, this RP is 8 centimeters. So it'll be 4 here and 4 here. So that means this is also 4. So MS is 4. MS is 4. And then similarly PT is also 4. PT is 4. See. And here the substitutions here, OP and NQ. OP, this is 5. OP is 5. And NQ is 11. NQ is 11. So how do we simplify? 2 1s are 2 2s are. 2 1s are 2 2s are. It's multiplication. Then 5 plus 11, 16. 16 into 2, 32. 5 plus 11, 16. 16 into 2, 32. So this one is 32 centimeters square. This one is 32 centimeters square. So the area of the hexagon is 32 plus 32, 64 centimeters square. Is Aman's method of calculating the area of the regular hexagon. Ridhima's method is she's divided the figure into 2 triangles and 1 rectangle. So let's find the area of the triangle MNO. What's the formula, children, to find the area of a triangle? Half into
PH, ma'am.
Half base into height. Half base into height. So in triangle MNO, if you take MO as the base, NS is the altitude. Half base MO into NS altitude. So that is half into, how much is MO? We just understood that RP is 8. RP, this full thing is 8. That means MO is 8. MO is 8. MO is 8. So half into MO is 8. Into this one. Now this full thing is 11. This full thing is 11. Okay. So it's divided into 3 portions. See here. See here, this full thing is 11. This full thing is 11. It's divided into 3 portions. 11 is divided into 3 portions. There's one portion here, there's one portion here, and there's another portion here. The sum of these 3 pieces is equal to 11. Because here it's 11. This one is 11. From here to here is 11. That means from here to here is 11. And that is divided into 3 pieces. This piece, and this piece. Now clearly, if this is 5, this is also 5. See this one, 5. So this is 5. So 11 minus 5 is 6. So it has to be 3 here and 3 here. Do it again. This full thing is 11 centimeters. And this is divided into 3 portions. 3 portions. There's one part here, and one part here. Now we know that this one from here to here, this is 5 because from here to here, this one is 5. The side of the hexagon, each side of the hexagon is 5. So since this is 5, this is also 5. Now 11 minus 5 is 6. So it will be 3 here and 3 here, which means NS is equal to 3 centimeters. NS is equal to 3 centimeters. Same thing for the other triangle. Half into base RP into height QT. Base is 8. This one is 8. And this height is 3. And for the rectangle, L into B, the formula to find the area of a rectangle is length into breadth. Length into breadth. Length into breadth. This length is 8 and the breadth is 5. This length, this one is 8 and the breadth is 5. Length into breadth, area of a rectangle. RP into OP, 8 into 5. Add everything, you will get the same thing. 1 plus 2 plus 3 will give you 64. Please complete, children. Any questions you can ask me? Yeah. Yes,
I
ma'am.
have a doubt.
Yes.
Ma'am, how can NS be 3 centimeter, ma'am, and not 4 centimeter?
Which one, ma'am?
Ma'am, NS and
N
PR. I mean QR.
NSN. Okay. You're asking about NS. This one, right? NS.
Yes, ma'am.
NSN.
QR, ma'am.
QR. Huh?
Yeah, ma'am.
Why QR you're asking? QR is 5, right? It's a side of the hexagon, 5 centimeters.
I mean, ma'am, the T was seen as R, ma'am. QT, ma'am.
QT, yeah, that's why I ask you. Okay. Okay, you're asking me about NS and TQ, correct?
Yes, ma'am.
Okay. So how much is it from here, from this point to this point? That is this length. What is this length?
11 centimeter, ma'am.
11 centimeters. It's given it's 11. So that means from here, see, instead of showing you that this is 11, instead of giving you this is 11, they've marked it outside like this. See, from here to here is 11. Is what is marked outside. From here to here is 11. Is what is marked here. See, from here to here, this length is 11 centimeters. So that means clearly Clearly, this is 11. Yes or no? This is 11. Correct?
Yes.
Okay. Now, this portion is a rectangle. This portion is a rectangle. This portion is a rectangle. Yes or no? See, it can be a square also, but it's a rectangle. It may be a square. That's okay. But is it a rectangle in the sense opposite sides are equal? Opposite sides are equal. This one is a rectangle. Yes or no?
Yes, ma'am.
Okay. How much is this one OP? It's 5. Why is OP 5? Because it's the side of the hexagon. Correct?
Yeah, ma'am.
Okay. Now, given that this is a rectangle, opposite sides are equal. So this one is also 5. Correct?
Yes, ma'am.
Okay. Now the total length is 11. Correct?
Yeah, ma'am.
11 minus 5. How much is it?
8, ma'am. I mean, 6, ma'am.
6. Now 6 has to be divided equally between this and this. The figure is proportional. Now we can, it's not that why this can, the remaining is 6, why this can be 5 centimeters, this can be 1 centimeter. It's not like that. It's proportional. So now that this is 5, because this is 5, this is also 5. Opposite sides are equal. In this rectangle, opposite sides are equal. So 5, 5. So 11 minus 5 is 6. And 6 is divided equally. That is 3, 3. 3 centimeters here and 3 centimeters here. Am I clear?
Yes, ma'am.
Okay. Very good, Swati. That's what I want all of you to think. Please ask me. Yeah? Yes? Louder, children, louder. Bhavishya or Nandana? Yes, Bhavishya?
I'm having doubt in Aman's method.
Aman's method. Yes, please ask me.
How we are multiplying that 1/2 5 plus 11 4.
Okay. So this one is a trapezium. Aman has divided the hexagon into 2 trapeziums. One trapezium is here. He's connected NQ. He's connected NQ. This one is a trapezium. MRQN is a trapezium with this side parallel to this side. See, just rotate this trapezium. Just turn this trapezium. Just rotate this. It look like this. Sorry. This dots. Rotate, just turn this trapezium. It look like this. Just turn this. Turn this one, it look like this. So now these are the parallel sides. These are the parallel sides. So Aman has connected the diagonal NQ, the diagonal NQ, and that way he has 2 trapeziums, MNQR and NOPQ. NOPQ. This one. Is that understood, Bhavishya?
Yes, ma'am.
Okay. Now, what's the formula to find the area of a trapezium? Half sum of the parallel sides into distance between them. So we have to identify the parallel sides and the distance between the parallel sides. That is why we draw this, line segment or this perpendicular MS, because this is the distance between these 2 parallel sides. And in the other trapezium, we have taken up the perpendicular PT because that is the distance between these 2 parallel sides. These 2 parallel sides. The parallel sides are in this trapezium. This side is parallel to this. The trapezium is like this, like this. The trapezium is like this. This side is parallel to this side, and this is the distance between the parallel sides. It's turned, the trapezium is rotated. See here, it's like this, no, the trapezium. The trapezium is like this. These two are the parallel sides. And this is the distance between the parallel sides. Just turn it, it will look like this. Rotate the trapezium, it will look like this. Yes or no? Bhavishya?
Yes, ma'am.
Okay. So now in this trapezium MNQR, this one and this one are the parallel sides, MR and NQ, MR and NQ. See here, you should take the full thing. NQ is the other parallel side, this full thing. MR is one parallel side, NQ is the other parallel side. In the other trapezium, OP and NQ are the parallel sides. OP, this one, OP, this one is parallel to this one, NQ. So OP and NQ. The distance between the parallel sides in the first trapezium is MS. In the second trapezium is PT. The second trapezium is like this. It's like this. This is parallel to this, and this is the distance between the parallel sides. So now the length of the parallel sides. This one is not 11. This is the side of the hexagon. This MR is the side of the regular hexagon, which is 5. NQ is 11. NQ is 11. MR is the side of the regular hexagon, that is given to be 5. And NQ is 11. It's marked outside, 5 plus 11. Distance between them, this full thing is 8. From here to here is 8. This full thing is 8. So it will be 4 here and 4 here. And since this is a rectangle, opposite sides are equal. So this is also 4. See, it's marked here. From here to here is 8. From here to here is 8. That means from here to here is 8. So it's 4 here and 4 here. Now this is a rectangle. This one is a rectangle. This one is a rectangle. Opposite sides are equal. So this is also 4. So distance between the parallel sides, 4, 4, 4, 4. Is it okay, Bhavishya?
Yes, ma'am.
Okay.
Ma'am, I'm having doubt in Regima's method also.
Yes, please ask.
Ma'am, how we are multiplying 1 by 8 into 3?
1 by 2 into 8 into 3, yeah?
Yes, ma'am.
Okay. What is the figure MNO called? MNO. What do you call it? Is it a rhombus? Is it a rectangle? Is it a trapezium? What is it? MNO?
Rectangle.
MNO is a rectangle? MNO, Bhavishya?
It is a trapezium.
No, darling. MNO, there are only 3 vertices. No, how can it be a trapezium? A trapezium has 4 vertices. If there are 3 letters, that means there are only. It's a triangle, yeah. It's a triangle. MNO, that's all. Only 3 vertices are there. MNO. So it's a triangle. If the trapezium is a quadrilateral, there'll be 4 letters in the name. A, B, C, D, T, Q, R, S. There'll be 4 letters. If it's a trapezium. MNO is a triangle. How do you find the area of a triangle? Half base into height, correct?
Yes, ma'am.
Half base into height. Now, which line segment represents the base of the triangle?
M and O.
You know, we don't say M and O, we say MO, line segment MO. M and O are the points or the vertices. M is a vertex, O is a vertex of the triangle. We say line segment MO. MO is the base. And which is the corresponding altitude? Which is the perpendicular on MO?
N.
NS. NS, yes or no?
Yes, ma'am.
Area of a triangle is equal to half base into height. Base is MO. into corresponding altitude NS. And MO is 8 because it's given here. It's marked here. See, from here to here. From here to here is 8. So this one is a rectangle. This one is a rectangle. This one is a rectangle. This one is 8. It's marked. It's given here 8. This one is 8. So if this is 8, if from here to here is 8, opposite sides are equal. So this is also 8. So base of the half base into height, base of the triangle is 8 centimeters. And height is this one. This is the height. This is the height. You understand how the height is 3?
Yes, ma'am.
How? Explain. How?
Ma'am, we are having the base as 8 centimeter, ma'am.
Okay.
After that, for N and S, the height is 3 centimeter because
How much is NQ? How much is NQ?
NQ is 11 centimeter, ma'am.
Very good. NQ is 11 centimeters. Now this is a rectangle. This one is a rectangle, correct?
Yes, ma'am.
Okay. How much is this one? How much is OP?
OP is 5 centimeter, ma'am.
OP is 5 centimeters. Now in a rectangle, opposite sides are equal, correct?
Yes, ma'am.
So then how much is ST? This is S, this is T. How much is ST?
5 centimeter, ma'am.
5. What is the total length NQ?
11 centimeter.
11. 11 minus 5?
11 minus 5, 6, ma'am.
6. 6 divided by 2?
3, ma'am.
3. So NS is 3 and QT is 3.
Okay, ma'am.
All right. Very good.
Yes.
Yeah. So that's how you find the area of the two triangles, half base into height, half 8 into 3. And what about this, Bhavishya, rectangle MOQR? Sorry, not QR, MOPR. MOPR. This one is a rectangle. How do you find the area of the rectangle? MOPR.
Yes, ma'am.
What's the formula to find the area of a rectangle?
Ma'am, L into B square.
Length into breadth. So length is RP. Breadth is PO. How much is RP?
Ma'am, RP is 8, ma'am.
And PO?
5 centimeter.
5. 5. So length into breadth, 8 into 5. So the area of the triangle, the area of the two triangles plus the area of the rectangle is equal to the area of the hexagon, MNOPQR. Correct?
Yes, ma'am.
Very good. Yes, so thank you, Swati and Bhavishya. By the way of your questions, I think the answer must now be clear to all of you. Still, if you feel you have a question, think about it, try to help yourself. Otherwise, you can ask me in the next class. It's time. Some of you might have not had your dinner, so I'll not take more time now. Just go through the answer, children. If you still have any questions, you can get it clarified in the next class. Or take a screenshot in case you have not completed working the answer. Please take a picture.
Yes.
Yeah. So class, use the emoji. Raise your hand. Andana, Bhavishya, Swati, and Harshita. Very good. All right, children. That's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you,
Thank
ma'am.
you. Good night.